midpoint. This gives us 6 plus 2, which is 3, and 6 plus 4, which is 18, divided by, which is 14 divided by 2, giving us 7. So the midpoint will be 3, 7. Good. So if you want to find the midpoint of a line, this is the formula. Midpoint, x1 plus x2 divided by 2, y1 plus y2 divided by 2. So you can try this on your own. You can try this on your own. Let me write it here. So you can try this on your own. Find the midpoint. Find the midpoint of have A 6, 2, and B -1, 4. Find the midpoint of that. That's Roman 1 and Roman 2. Yeah, A is 0.5 and 1, and B is 2 and -3. Remember, the formula for midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. The concept of midpoint is very useful, especially when dealing with the also equation of a straight line under the perpendicular bisector. For you to find the point where the bisector is passing, you need to use the midpoint formula or the midpoint rule to find the coordinates of that point. So it's very important, don't forget it. Let's go to our second last concept, which is the magnitude. Magnitude of a line. At the beginning, we said that magnitude of a line means the length of a line. Now, I'm going to give you an example. And I also said that for you to understand the concept of magnitude and to be able to find the magnitude of a line, you should first be able to find or to calculate the position vector of a line. Good. I'll give an example here. Let's say you have a coordinate system here, and you have the position vector of line OA. OA is 2, or let's say 3 and 4. This is the position vector of our line OA. So we can say our line OA is here. The value of O is the starting point of the midpoint, which is 0, 0. So meaning the range of our x is 3. It's 3 units, 1, 2. This is 3 units, that's the value of x, so here it's 3 units, meaning the change in x value is 3. And the change in y value is 4. 1, 2, 3, up to 4. 4 is here. Good, that's 4. Good. So, this is the value of x, and this is the value of y. To find the magnitude of a line OA, which is here, it simply means finding the length of this side of this line OA, the length of this line OA. So, lucky enough, we have Pythagoras who came up with the Pythagoras theorem that can help us find the hypotenuse of this line OA, because we can treat this as our opposite or adjacent, and this one also as opposite or adjacent, whichever. So if we have this as 4 and this as 3, from Pythagoras theorem, we know that a squared plus b squared gives us c squared. And at this point, we have our a, we have our b. So for us to find c, we simply find the square root on both sides. So you'll find that in order to find the value of OA, which is the hypotenuse c, it's simply the square root of a squared plus b squared. But now remember here, we don't have a and b. The value of a here is x, so this is x, and here it's y. So substituting them back in our formula, you'll find that the distance OA will be, I'll tell you what this means, OA will be square root, instead of a, we write x squared plus y squared. Now, OA with these two parallel lines simply means that that's the magnitude. So this is how we represent magnitude. If you have magnitude of a line U, then the magnitude of that line will be represented like this, using two lines, parallel lines on the opposite side. So these lines indicate that this is the magnitude. So magnitude of line OA will be the value of x squared plus y squared, the sum of it, then the square root. It gives you the magnitude. Let's try one example, and then I'll give you another example so that you can try on your own. Good. Suppose you have a vector OA. OA is 2, 6, and you have OB is equals to -2, 4. Good. So find the magnitude of AB. So we want to find the magnitude of AB. In in order to find the magnitude of AB, first we have to find the position vector of AB. And how do you find the position vector of AB? You have been given that the position vector of OA, if you can represent this on a coordinate system, OA is 2 and 6. So this is our O, this is our A here. It is 2 and 6. This is in column vector. And then our OB is -2, -2 and 4. Okay, that's A, which is 2, 6. And you have our B, let's assume it is here, which is -2 and 4. Don't look at the sign. I'm just trying to present it here. But remember, we want to find the magnitude of AB. For us to find the magnitude of AB, first we need to find its position vector. And how to find the position vector of AB? We are at A, we are going at D. So it simply means that we shall take AO, then plus OB, but that's the long way. OA and this OB, so the arrow points towards the terminal point. That's the long way. For us to find AB, we simply take B minus A, which will be, the value of B is -2 and 4, that's the shorter way, and then A is 2, 6. Giving us -2, that's -4. 4 minus 6, giving us -2. So this is the position vector of our line AB. Now, if we can represent our line AB here, and we have the x component is -4, the y component is -2, we want to find its magnitude, its length. First, you need to find its position vector. After finding the position vector, we can now substitute it in our formula, where we said that magnitude of AB will simply be square root of the value of x squared plus the value of y squared, which will be equal to square root of -4 squared plus -2 squared. This one will give us square root of -4 squared is 16, and then -2 squared is 4. So it will give us the square root of 20. We can give our answer in third form, and that will be 2 root 5. Don't forget to put their units, because we don't know the specific units used, so we use the word units to represent magnitude. So magnitude is the distance, and that's how you find the distance. This is the formula for finding the magnitude of a line, the distance. So don't forget that formula. So I'll give you one example to try on your own, and then you can proceed to our last concept of translation. Good. So I can leave this. I hope you have copied. So given that we have OA, position vector OA is 2, 6, and have AB is 6 and -8, and point, you have a point here, M is the midpoint of AB. So you have been given OA is 2, 6. You have been given AB, but you have not been given OB. So you will need to find OB. But you have been given that the midpoint of AB is this one. No, the midpoint of AB is that one. So find OM. They want you to find the magnitude of OM. So try to work that out and see if you can handle it. Remember, these two parallel lines on the opposite side, they indicate that this is a magnitude. And this arrow on the top, it indicates that this is a vector. That's how we denote vectors. Good. So let's go to the last part, where we are talking about translation of vectors as a form of transformation. Translation, spelling is correct. So when we talk about translation as a form of transformation, we know that transformation is changing an object from one position to another. It can be changed in shape or not in shape. For example, transformation, it can be an enlargement. So when talking about enlargement, the object will change in shape. It can increase or it can decrease in shape. But under translation, we change the position of the object, but the size of the object remains the same. It's, for instance, we can take a ball. We have a ball here. Then this ball is kicked towards this point. This is A and this is B. So the point is kicked from point A to B. So the ball will come here. So the ball has changed in position from A to B, but it has not increased or decreased in size, it is still the same volume or the same size as it was initially here. That's what we mean by translation. Changing the position of an object without change in shape. Good. How does that happen? Let's go to our coordinate system and see how that happens. Suppose this is our x-axis and this is our y-axis. And we have a point here, 1, 2, 3, 4, and 5. And have 1, 2, 3, 4 here. Let's take a point here. Let's take a point here. Let me just make it. So this is 1, 2, 3, 4, and 5. This is 1, 2, 3, and 4. So let's take a point here, A. This is our point A. Now the coordinates of a point A will be the value of the x is 2. So it means our A will be the value of the x is 2 and the value of the y is 2. That's good. And let's take that this A is translated, because we're talking about translation, not transformed, but translated, because we're talking about translation and not transformation. So it is translated from point A, let's say to point B here. Let's put it here. So point B, the coordinates of point B will be, that's point B. So the coordinates of point B will be, the value of the x is 5, the value of the y is 4. So point A is translated from 2, 2 to 5, 4. Let's see. The change in the value of the x from 2 to 5 is how many units? The position of A to B has changed by 3 units on the x-axis. That's from 2 to 3, 3 to 4, and 4 to 5. So the change in the value of x is 3 units. The x-axis have changed by 3 units. What about the y-axis? That's the position of the point A was initially here. That's at point 2, and then it changed to point 4. How many units are those? 1, 2. So the position of point A has changed by 2 units to point B. And because when going to the right, it is positive, and when going upwards, it's also positive. That's why our values come here to be positive. So you realize that on the x-axis, the position of B have changed by 2 units, and the position of y have changed by 2 units. On the x-axis, 3 units. On the y-axis, 2 units. How do you achieve that? You see, if you take this B minus A, that is 5, 4. This is our initial point. This is our terminal point. So we always take the terminal. And this one here, because we're talking about translation, we shall treat this as our object. And then after translation, it will give us our image. That's how it always works. So if we take our image here minus our object here, which is 2, 2. What do we get? 5 minus 2, 3 for the x-axis, and 4 minus 2, we get 2, which is the change in y-axis. That means that if we take image minus object, it gives us what? Translation. So this is the formula we're going to be using here under translation. In order for you to remember, if you take image minus object, you get translation. Let's do one example. Just one example. But remember that I said translation will be equal to image minus object. If we can take object on the other side, you can say that translation plus object is equals to image. So this one sounds better than this one. If you take object plus translation, you get image. Object plus translation is equals to image. Example, let's just do one example, and then I give you another example to try on your own, and then you can call it the end of a topic. So say point A with coordinates 2, -4 is mapped into point B. So point A, 2, -4 is mapped into point B, let's say 0 and 6, by a translation T, which is unknown. Find the image of a point C with coordinates 4 and -1 under the same translation. Good. So I want us to go through the question again and interpret it. We have a point A. This point A is mapped into point B. We don't need to use a coordinate system or a Cartesian plane right now, because you now know the formula that when you take object plus translation, it should give you the image. So we have a point A is mapped into a point B under a translation T. Now we don't know the translation, but we can find it because we have the coordinates of the image here and the object here. But that's not what they want. They want you to find the image of another point C, which is translated under the same translation. What does it mean? They want you to find the image of C. And remember, object is equals translation plus image. Let's begin the second part. The question. The question says, find the image. So you want the image, meaning you don't have the image. And the image of a point C. So point C is the object. So you have been given the object under the same translation. They want you to find the image of this object under the same translation. And remember, we have the object, which is C. We don't have the image. That's what we want to find. And you don't have translation. And for us to find, because this is just an algebraic equation, it has two unknown, right? And you see it has two unknown. So if it has two unknown, we can't solve it if there are not two equations, because it has two unknown, and it's an algebraic, you have to make it one unknown. So we have two unknown here, translation and image, but our main point of concern is finding image. So how do we find image? We first need to find the translation. And for us to find translation, we use the information that you have been given in the first part. You have been given that a point A, we have here an object you have been given, is mapped into an image, but we have not been given the translation, but you have been given the image is 0, 6. So you have been asked that a point 2, -4 is mapped by an unknown translation T into 0, 6. So we need to find this translation, because we can find it now here. After finding the translation, we now use it here on our second part to find the image of this object C. So how do you find T? Simple mathematics, 0, 6. This one, it goes on the right side, and because it's positive, the sign changes to -2, -4. This will turn to be 0 minus 2, giving us -2, 6 minus -4. Take note of the two negatives. A negative, when you multiply it by a negative, it gives you a positive, so we shall get here, it's 10. Good. Meaning that our translation is -2, 10. And that's what we were looking for, translation, because we cannot find the image here without the translation. So to find the image of C, we have the object is 4, -1, plus translation, which you just found here, -2 and 10. It will give us 4 minus 2, which is 2, -1 plus 10, which is 9. So the image of C will be 2, 9. If you are asked to write in coordinate form, you write it as 2, 9, because this one is in column form, or column vector. We talked about that just a few minutes ago. Good. So this is how they normally set the question. They will give you the first information to help you find the translation. And then now you'll be asked to find the image of this another point C using the same translation you found on the first part. So you should be able to interpret the question before you work it out. And that needs practice. So this is the assignment on translation. Assignment on translation. Assignment on translation. Just one question. A point A with coordinate -2 and 4 is mapped into A prime, which is 0, -6, by a translation. Roman 1, find T. So find the translation. That will be 1 mark because you can do it offhead. And then the second Roman, find the object, find the coordinates of the object, find the coordinates of the object find the coordinates of an object whose image is, let's say, 2, 4 under the same translation. The question might be twisted a bit, but with the formula, you don't need to worry about anything, just need to substitute in. Now, just to finalize, we talked about definition of vectors. No one will ask you that, but you just need to know it so that you can understand what we mean by vectors. So we also talked about equivalent vectors. They'll be very useful in diagrams. And also, you need to know how to represent a vector. You just don't write values, or maybe you write vector like this and you leave it that way. You need to put that wave line here. And if you're talking about vector AB, if the direction is from A to B, then you must indicate with an arrow. And also in examination, if you're asked to find AB, they ask you to find AB, you should know the language. What does it mean? It means they want you to find the magnitude. Or they can use the word magnitude directly, or use the word length. They can ask you to find the length of AB. Okay. So they can ask you to find the magnitude or length, or simply use that language, AB, and two parallel lines on the opposite side. So you should also need to know that. And then also remember the midpoint formula. Midpoint formula, it's very important when working out with vectors 1. And also, this information will also help you to understand vectors 2, because vectors 2, it mostly bases on the knowledge of vectors 1. You cannot understand vectors 2 if you have not understood vectors 1. So this is the preliminary topic in vectors. Make sure you understand it. Also, remember how to find magnitude of a line. Magnitude, before you find the magnitude of any line, first make sure you find the position vector of that line, because the formula is just simple. Magnitude, not magnitude, but yes, magnitude. We said magnitude is square root of x squared plus y squared. If it's a 3D vector, then you can also add z squared. There's no problem. That's the same formula here. And remember, the units is units, not centimeters, not kilometers. You represent them by units. And then lastly, a question on translation. Yeah, it always comes. And if you want to score it right, just note the word translation. Translation. They always use the word translation because they can be asking you about rotation or reflection. This one, if you want to find it, you can check it in revision books, solving problems, and you have many other revision books. In Made Familiar, it's incorporated together the topic of transformation. That's enlargement, reflection, rotation. That's where you'll find the questions on translation. So go and check it, and then if you find any question, you can make a reference from what you have just studied here. So my name has not changed. I'm still Byron. You can meet in our next class, Vectors 2. And enjoy your day.